Ooh, so let's talk about circles generally. What is a circle? Yeah, as you can see, a circle in generally is being given as a point AB, for instance. If it's got a radius r, then we can make the point here, for instance, to be our center. If we can, use this point and with a known radius and a compass, when we turn it around, we'll be able to create a circle. So this is the general equation of a circle. X minus a squared plus y minus b squared equals r squared. As you can see, so where a and b are the x and y coordinates of the circle defined as the center of the circle, and r is the radius. So with a general equation of a circle, x minus a squared plus y minus b squared, it's called r squared in mind. We can solve in different ways. Okay, now let's see. How did we get this equation of a circle? So let's look at it from this perspective. Because we can't just come out and say, oh, come on. The equation of a circle is given as x minus a squared plus y minus b squared is equals to r squared. We need to be able to explain why x minus a squared plus y minus b squared is equals to r squared. Okay, so let's see. Now, let's analyze this, because we shouldn't just accept it. So, if I come here, draw, change my distance, check my nice color, blue, lighter blue like this will do. All right, so now when I insert a circle here, we're going to take it step by step. So this is a circle. Okay, this is our big circle. Okay, now this big circle, definitely, if we draw a line, okay, through this circle, then we'll be able to define the x and y axis. So, for instance, if I decided to make my x and y axis in the form of this color, then I would say, picking a line here, okay, this will be, for instance, the y axis, okay, and this will be the x axis. So let's go and pick one. So this will be our x axis. This will be our x axis. Okay, so x axis. Okay, let's drop it well. So this is the x axis. So when we draw this, there's an x axis. Okay, so now we're saying something. Now look at it and see how this equation came about. Okay, so now if we have a radius, let's see, let's pick this one. Okay, so this is the center of the circle. Okay, center of the circle, and a radius. Okay, this is a radius. Let's say this is the center of the circle, and this should be a radius. So when we draw any line that comes through from here, from any point to this point, okay, as far as it intersects with the circle, okay, then we can say that it's a radius of a circle. In the same way, if I draw a line through here, that would be a radius. Likewise, when I draw a line through here, this will be a radius, and I draw another line to anywhere, let's say from here to this, to the center of the circle, then what can I say? Then I can confidently say that, this point, from the distance, so the distance from here to this point is a radius, and from this point to this point is also a radius, and from this point to this a radius, and that is the same way. Now, if this is our x-axis and this is also a y-axis, then when we resolve this, okay, then there will be a change in y-axis, and there will also be a change in x-axis. Friends, now, knowing this point here, C, let's call it C, to be A, comma B, then here being our x-axis, that means from here to here. Let me illustrate it well. From here to here, pick a yellow. From here to here, yellow ochre. All right. So from here to here, okay, so the difference between this point over here, okay, and the difference between here, this point, okay, and the difference between this point from the center, yeah, from the center, so from the center, okay, to that, there will be a change, a difference between the point in y-axis and the point in x-axis. So for instance, since we know the center to be AB here, then we can say change, okay, change in y-axis, we will call it y-axis, and the difference will be minus b. Then the x-axis here, the difference will be x, we subtract the value a. Now, you know the radius here is what? R. And since these 2 points meet, here will be 90 degrees. So if we call this one at our point O, A, B, okay, so when we resolve it down here, it's going to be our R being the radius, and this here will be 90 degrees, and the difference here being the y minus b, and the one here being x minus a. The certain angle theta, this is the center, which is x, a, comma b, which is x and y axis respectively. Then by using the Pythagoras theorem, we can say that the square of the hypotenuse is equal to the square of the adjacent plus the square of the opposite. Friends, this we know from elementary. So by substitution, we can say that the hypotenuse being r here, so there will be r squared. Then the adjacent will be in the x minus a squared plus The opposite, that will be what? Y minus b squared will give us this equation. And this equation, generally, we know it becomes to be called the center of the equation of a circle, because we are able to generate this equation from this. Y minus b squared equals r squared. So that is how this equation came about. Now, understanding this is vital. You can't just be able to equate, just the equation, the whole coordinates because r squared, or you can also say that this is the general equation of a circle without being able to understand the basis within which the equation was derived. So this actually becomes the equation of a circle, okay, with the coordinates, yeah, as you can see, the coordinates x and y axis, okay, derived from x and y. So this is the equation of the circle. So now, if we, for instance, we've been given a known values, then we'll be able to, derive an equation. For instance, if we, a question for instance, if we have a coordinate to be 2,3, and a radius to be 5, then definitely we can be able to, write the equation of a circle with ease. Okay, now so let's see. So using this, if you put this the values into this equation, we're going to get x minus 2 squared and a y minus 3 squared equals to 5 squared. Okay, and this will be equation of a circle. So we see x minus 2 squared plus y minus 3 squared is equal to 25. So this becomes the equation of a circle. Now, this, in the same way, okay, if we have any coordinate at all, we can be given a coordinate to be maybe square root of 3, 2, okay, and r to be equal to pi on 2, and we have been asked to find the equation of a circle, okay. Or what we have to do, we have to substitute the respective values into the equation. So therefore, we can say that since this is x and this is y, we say x minus set of 3 squared, okay, plus y minus 2 squared is equal to pi on 2 squared. Okay, and this will be the equation of the circle. So this can be x minus set of 3 squared plus y minus 2 squared is equal to pi squared over 4. You see, so this is the equation of the circle. So you see, this is the equation of a circle, and in everywhere we go, this is how we, we can find the equation of a circle. Now, looking at this one, let's call this one B, and let's call the one we derive here as A. Now, so for the A, we have x minus 2 squared plus y minus 3 squared is equal to 25. Okay, which is also the equation of a circle. Okay, but this can be expressed in different form. So don't be confused when you see something of the sort. So all what we do is to bring this equation down here, we expand it. So this x minus 2 squared plus y minus 3 squared is equal to 25. When we expand this elementarily, this will be x minus 2 plus y minus 3 and y minus 3 is equal to 25. And further expansion, we say that x squared minus 4x plus 4, okay, and this is y minus squared minus 6y plus 9, okay, is equal to 25. Friends, now we can say that x squared, okay, plus y squared, as we separate, minus 4x minus 6y, okay. Don't forget we have a 4 here and 9 here. So we say plus 4 plus 9 minus 25 is equal to 0. Do not be shaken. It's the same equation of a circle that we are now expanding. So we can say that this finally can be written as x squared plus y squared minus 4x minus 6y plus 13 minus 25 is equal to 0. Friends, now, this, somebody may see this, a student may see this one, and they will get confused. They shouldn't get confused. It's the same equation of a circle that we have, expanded, as we have expanded it to this form. Sorry. So now, if you look at this, what comes into mind, that equation of a circle can be given in a different form. So that means you must be alert that equation of a circle can be given in a different form, not necessarily, not necessarily is going to be the form we saw earlier. Okay? So, meaning that finally the equation can be now be written as what? X squared plus y squared minus 4x minus 6y, okay, plus minus 12 is equal to 0. So this becomes that equation that we have expanded to become this. So now you see this equation, okay, and the one that is x minus 2 squared plus y minus 3 squared is equal to 25 are the same. You see, they're the same equation. So, in the same way, we can also decide to expand the B part. And let's see how best we can do that one as well. Okay? Now, let's take our time to understand this properly. Okay? So, that one is x minus root 3 squared plus y minus, the y minus 2 squared, y minus 2 squared is equal to pi square of 4. So this, we have to do it the same way. So let's take our time and do it. So x minus z root 3 into bracket s minus z root 3, okay, plus y minus 2 is equal to pi square of 4. Okay, then we say this will be x squared minus 2 root 3 plus, root 3 times root 3. So then you see this will be plus 3. Okay, so plus 3. So that is made life easy for us. Okay, so now let's handle the second one, and that is y squared minus 4y plus 4, okay, pi squared on 4. Okay, so now we can separate, we can do our separation. Don't get confused. Separation, so we separate all the x's on one side, and we separate all the y's in one side, and normal values as well. So we have x squared plus y squared, okay. This here, don't forget it's x. Okay, so now here we have minus 2 root 3 into bracket and put into bracket x. Okay, then we have a minus 4y. Okay, then we have plus 3 plus 4 minus pi all squared over 4 is equal to 0. Okay, so now eventually our equation, can be written as x squared plus y squared minus 2 root 3 x minus 4y plus 7 minus pi on square root of 4 is equal to 0. So this is also the same equation of a circle. So in effect, we shouldn't be confused. This equation here is the same as x minus sec 3 squared plus y minus 2 squared is equal to pi squared on 4. Okay? And this are the same equation. So, in saying that, we have seen that, the whole equation of a circle was derived by the knowledge of our almighty Pythagoras theorem. Okay, as you can see from the diagram, you don't need to memorize this, but you need to understand the basic concept that makes life easier. If you really want to have a solid grip in mathematics, you must always understand the first principle, how to derive the equation. So with that will give you a grounding that you'll be able to handle any equation at all. So in this, so now see, as you can see, we have this Pythagoras theorem, we have this equation. We've been given a question which it says 2, 3, r is equal to 5. We'll be able to get the equation. Now, there is a question that usually comes. Now they can give you a question and ask you to find the centers and the radius of the circle. So they can ask you to find the center and a radius of a circle with a known equation. Okay, so the next time we meet, we are going to look at how to find the center and the radius of a circle with a known equation. With a known equation of the center of the circle. So I don't want to take much of your time. Please, you can take your time and go through step by step. Okay, friends, if you have any question that baffles your mind, then you can contact me for me to break it down further for you. Okay, without further ado, I will say bye. Please go through it and see me if you have any problem.